So hey, my name is Juan Riaza. So this is a talk defining data pipeline workflows using Apache Airflow. The slides are already online at speakerdeck.com/Juan Riaza. So who am I? Well, I'm Juan Riaza. I'm a software developer at Idealista. I'm an open source software enthusiast. I'm a Pythonist and Django nerd. I've been working with Python for more than 10 years. And I'm trying to tame gophers, if you know about Golang. And I have a curious hobby. I like to reverse engineering mobile applications. That's I sent another proposal for reverse engineering Android applications, but it was finally this one, the Airflow one. And I also have some normal hobbies such as cooking and reading. So I'll give you 30 seconds just to read this comic strip from XKCD. Perhaps some of you have been already in that situation, right? If you've been building ETLs or data pipelines, they could get really complex, and sometimes you don't have that much control about them. So this is a bit of story. In the beginning, there was cron. I guess when we start developing ETLs or data pipelines, we always think of cron. Okay, we have to schedule a certain task at some specific hour, and we need cron. So let's imagine this imaginary 3 steps data pipeline, where we pretty much have the first step is about gather data. The second step is about just a simple ETL, and the last one is about reporting. So they have dependencies between them. That's one thing that we are going to suppose. And we have been checking for how much time they need, each step needs to run. So the first step runs at 10 p.m. And we know that it lasts just 1 hour, and of course, by midnight, the second step is ready for consuming the necessary data or dependencies from the first step, and so on. Well, that's pretty inefficient, right? Okay, we know already how much time we're using at each step. So we could just reduce the spare time between all of those 3 different steps. And we're happy. Now it runs way faster. But we could get into some problems. So let's imagine that the second step fails. So now we don't know what will happen to the third step. Pretty much worse. Let's imagine that the first step takes longer than usual, and it overlaps with the second step. So well, we're in the same situation. We don't have visibility about what had happened at all. So I call it this thing I call cron hustle. So we have lots of problems if you're using cron, such as managing dependencies. So there might be possible overlapping. Failure handling, do we need to retry a step? How do we handle failure at each step? How do we notify errors? We don't have metrics. Do we have visibility at all about what happens overnight? And well, it will be okay to have unified logs. I mean, we don't know in which language each step has been developed, and it will be okay to have unified logs from all of them. And I don't know if you have tried to develop a distributed cron. I've done it in the past for a young application, and it was a nightmare. And if you are working in a data engineering role, you perhaps maintain a calendar of batch jobs that needs to be done. And you're always wondering this: what happens if you have so many questions? And every day it's a new adventure, pretty much. So meet Airflow. Well, that was a nice animation. So overview of what's Apache Airflow. It's a platform to programmatically, that means that we define everything with code, author, schedule, and monitor workflows. It's pretty much the glue that binds your data ecosystem together. It's open source, written in Python, and was started in October 2014 by Mox Buchanan at Airbnb. There's a lot of really cool projects from that time at Airbnb. You might know as well about Superset. And it's been incubating at Apache Software Foundation since 2016. Now, the project is pretty strong. It's 550 contributors and increasing, 5,300 commits, and over 10,000 stars at GitHub. And well, this was from yesterday. I had to modify the slides this morning because they were just celebrating that they had passed that 10,000 stars at GitHub, that mark. So there are lots of companies, really big ones that are using already Apache Airflow for their data teams. So it's not just a small thing that it's still incubating at Apache at this Apache Software Foundation. So what are the typical use cases for Apache Airflow? Well, pretty much ETL pipelines. That's the most common. But machine learning pipelines, predictive data pipelines such as fraud detection, scoring, ranking, classification, recommender systems, or just any general scheduling. Even the DevOps team calls Apache Airflow for lots of related tasks such as DB backups. But pretty much it could be anything. I mean, why not just automate your home's garage door or whatever? It's just a workflow orchestrator. So it could be anything, not just ETLs. So let's check a bit of theory about Apache Airflow. Airflow uses operators as the fundamental unit of abstraction to define tasks. So tasks are equal to operators. And uses what is called a DAG to define workflows using a set of operators. So DAG is the whole bunch of operators. So what is a DAG? So this is pretty much maths. It's a directed acyclic graph. And represents a workflow that's a set of tasks with a dependency structure. And each node represents some form of data processing. So if you have studied maths at university, you might know what's already a directed acyclic graph. So it does make sense for a workflow, how we represent a workflow. And this is how it looks like. Okay, with Apache Airflow, we have a nice UI, and this is just a simple workflow. Each box is just a task or an operator. So we have run this first, run underscore this underscore first, and then we have branching, and we could go one of those 4 ways, and then we join, whatever. But it could get more complicated. I mean, there are. This is, I don't know. It might be from the Apache Airflow website or some Airbnb slide, but it could get really complex. So let's make our first DAG. So this is going to be the graph, print underscore bash, sleep, and then print underscore Python. This is the simple. This is a normal Python file, .py. And we just define what's a DAG. We give it a name, commit underscore that. We tell which is a scale interval. In this case, this one, it runs weekly, on a weekly basis. And then we have instance of each operator. In this case, we're using a Bash operator and a Python operator. The first one, the Bash operator, each task needs to have a task ID. And the simple one is just a Bash command. We just execute echo commitconf, hello commitconf. And we then sleep for 5 seconds. And we have a Python operator that just calls a reference to a Python function. It's up there, print underscore commit. It's just waving hand, hello commitconf. And the last line, that's how we set up the hierarchy, the upstream dependencies. So first it's print underscore bash, then sleep, then comes print underscore Python. And then we have a nice UI, a website for checking how it looks like. Well, in this case, we just have our brand new commit underscore da. We can check the schedule, the owner, the written task, the last run. But there is more than that. This is a more complex image of a real DAG list. In this case, we have CuriosDB, GitHub to Redshift, whatever. So we can check who's the owner, the written tasks, the last run, or even if it has been failures or retries. Then this is when we can go in depth to check which is the status and how it looks like each DAG. We have a graph view. In this case, it's the same. Print underscore bash, sleep, print underscore Python. But it could be more complex. And a really cool thing is that we could just click on any box, any task actually. So we can check the task instance details, we can view the log, we can run it, or we could clear it. That means that we could just rerun each task and caring about dependencies or not. We'll check that, how that works. And then we have this tree view. So in this case, each column it's a whole DAG run. This has been running for 4 weeks, but we could check a more complex. In this case, on the first runs, there's been some failures. So the good thing is that we could clear the state of a failed task and just retry that one without retrying the whole DAG. And then we have what's called a Gantt visualization. In this case, it's how much time has it taken to each task to run. Well, we're sleeping for 5 seconds, so that's take much time. And it looks like print Python takes longer than just printing with Bash. That makes sense. That makes sense. But in this case, this is a more complex DAG, and we can see how much time that it does take for each task to run. And the cool thing is that we could see how this looks like over time. So we could check if a task has been increasing their time, or if it's taken any longer, or we could debug the DAG itself. So we have 3 kinds of operators. We have action operators. Pretty much we perform an action locally or make a call to an external system to perform another action. Transfer operators, they're just for moving data from one system to another. Sensor operators, we use them for wait for and detect some condition in a source system. So what are action operators in this case? Well, I have told you already to perform an action such as executing a Python function or just submitting a Spark job. So we could just run a Python function locally, but we could as well, I don't know, perhaps launch a Kubernetes cluster to run our workload, or create on the fly an AWS EMR Spark cluster to run whatever we want to do with the ETL. And the good thing is that we have lots of built-in operators that are already on the source code of Apache Airflow, such as Vars operator, Python operator, Docker operator to run a Docker container on the fly, email operator. And we have lots of community contributed ones. Some of them are of course commercial, such as Databricks, you might know them, AWS and GCP. So we could just automate and integrate all of those systems, such as, do we need to run a query using BigQuery? No problem. Google has already make a BigQuery operator and works out of the box. We have as well transfer operators to move data between systems, such as from Hive to MySQL or from S3 to Hive. So we have some of them built in, such as the Hive to MySQL transfer, S3 to Hive, but as well we have the community contributed ones, such as Databricks, AWS, or GCP. So do we need to move data from S3 to our local file system? We will do it. Sensor operators, those trigger downstream tasks in the dependency graph when a certain criteria is met. For example, checking for a certain file has become available on S3 before using it downstream. So we could have a DAG that runs on a daily basis, and we just need an external file to be available at any S3 bucket. So this operator will just check periodically the S3 bucket to check if the necessary S3 file is already available. And then it will just continue with the dependency graph until it gets done. We have lots of built-in as well operators. Hive partition sensor in case we need to wait for a Hive partition to be available. HTTP sensor, we could even call any external API and check any condition in order to continue with the execution of the DAG. S3 key sensor, of course, SQL sensor, FTP sensor, and of course the community, the usual suspects, the community contributed ones. So let's do a more advanced or complex example of a DAG. So let's wait for a key on S3. That's a file-like instance on S3 to be present in an S3 bucket. Let's add a new AWS Athena partition. AWS Athena, it's like Presto as a service pretty much. It works on top of S3. Run an AWS Glue job and wait until it's done. AWS Glue, it's a serverless Spark environment from AWS. And notify the data services channel at Microsoft Teams or Slack or whatever you're using at your company. Well, we have already an S3 key sensor. There it's built in. But we could develop as well our own operators. So in this case, I've already done an AWS Athena query operator and an AWS Glue schedule job operator and sensor, plus a webhook operator to integrate with Microsoft Teams. There's already a built-in Slack webhook operator, so you could just notify your data services Slack team about the status of your DAG. And can you see it? Can you see it okay? So pretty much we have instance of an S3 key sensor. We update the Athena partition, then we schedule a Glue job. So we schedule the AWS Glue job, and then we have a sensor to check when it has finished. We send an API call to Amazon. It just starts running the AWS Glue job. And with the sensor, we check if it's done already or not. And with the S3 key sensor, we check if the file exists. Okay, if it's really present. And then we notify our team. And on the last line, there is this dependency graph. And you might notice that there are some brackets over there. Why? Because Apache Airflow has a really cool template system that uses Jinja underneath. So this gets rendered on real time on each execution. So we have a variable available such as execution date by default, and it gets filled with the value of the execution date. So if we have this DAG with a weekly schedule, it will just get filled whatever is necessary. Okay. And the cool part. So imagine we have already developed our DAG, and what happens if the ETL script has a bug? But we haven't noticed until now, and it's been running for weeks. Okay, so what we could do is just do time traveling. We could travel past in time and rerun only the related tasks downstream. So we don't have to execute again the whole DAG, but just execute the parts of the DAG, the operators that has each, in this case, the part of the ETL, and without side effects. And well, this action of going back in time and rerunning parts of a DAG, it's called backfilling. And so let's check how everything fits together. This is the big picture. So this blue box on the left is how we interact with Apache Airflow. We have the UI, we have a CLI, and we have an experimental REST API. Everything is stored on a metadata DB, and we have a scheduler, which schedules, of course, DAGs and tasks whenever it's necessary, and delivers those tasks to the workers. So there is only a single point of failure at this moment using Apache Airflow. The scheduler, it's the unique single point of failure. We can replicate the scheduler. But I can tell you it's really hard to get to the higher limit of the scheduler. Companies such as Airbnb have some problems with the scheduler, but they are perhaps managing 8,000 DAGs at the same time, so not a problem for a medium-sized company. So the core components, we have the web server, so it pretty much is the Airflow UI. It's using Python Flask. The scheduler, which is responsible for scheduling jobs, and then we have different kind of executors. So those are the workers. We have local. In this case, it's just a Python process working locally. We have Celery. That's the most popular option, and it's just the de facto way of a queue-based task workers using Python. But then we have as well Apache Mesos and Kubernetes since a couple of months ago. So we can just run our workload on Kubernetes on the fly, on demand. And of course, the metadata database, and that could be pretty much anything from an SQLite to MySQL to Postgres. Anything that works with SQL Alchemy could be used as a metadata database. So those are the interfaces, the web server UI, the CLI, and the REST API server, which is a bit experimental at this moment yet. So the CLI. We have lots of different commands, but pretty much it's used to run the core services, such as running the web server, the scheduler, to perform some metadata DB operations like, well, schema, reset the state of the DB. To operate on DAGs, we could pause the execution of a DAG. We could trigger the execution of one of them. We could do some backfill. We could perform backfills directly from the CLI. And of course, we have lots of useful commands for develop and testing. So the web server UI, it does pretty much search for having a quick look into DAG and triggering and checking the task's progress. It does have error logging integrated. So the good part is with Airflow, each step could be, or each task or operator could be in a different language. We could have a step which is just Bash, another step which is just Python, Golang, or even an external service. But we have the information about what has happened on every step on a unified log that we can check at the web server UI. We can browse the metadata. We will check what's that later. That's XCOM variables and service level agreements, and check for historical stats. So that's the first beginner question when anyone starts to use Apache Airflow. How do we move data between one task and another? This is not Apache NIFI or any system like that. So in theory, all data processing and storage should be done in external systems. Okay, because we can't assume that all the operators are going to be executed even on the same machine, right? So Airflow has the metadata DB that contains the necessary data for each task to be executed, and contains the workflow metadata. We'll check how this works. But pretty much the metadata DB stores variables, those are static values, config values, and API keys. And we have this special term that's called XCOM. This is how one task communicates with another task. In this case, well, it's a short for cross communication. And it could be, for example, what's the file name of a file found by a sensor. So imagine we have an H3 key sensor. Well, using XCOMs, the next task will know what's the name of the sensor that needs to be used, right? But we don't need at that moment to get the whole H3 file locally. So pretty much we know we have a file. That's the path of that file. But we don't move data between tasks. And then we have a connections part to store GDBCs, authentication, and so on. So it does have batteries included. That means failure handling and monitoring. So we have retry policies and SLAs, retry policies. So we could have a backup time between each retry. So imagine a system is down, we could wait 3 seconds, 6 seconds, and so on. And service level agreements. In this case, we could have a service level agreement for a DAG and get an alert in case we have already out of the service level agreement. We have a smarter cron. Why? Because we're using code for developing our DAGs. We can have really complex rules, such as it's an even or odd day. We can even call an external API to know if we need to run a DAG. We could have complex dependencies, such as only run this task if all of the rest of tasks have failed, for example. And then we have the bug fields, already, and a really feature-rich template system, Jinja. It uses Jinja underneath. That it's a really cool Python project for managing templates. So let's talk about what are the best practices. So we have to think about idempotency, and it's a key concept while using Apache Airflow. We'll talk about this later. But Apache Airflow allows us to do, for example, to pipe all the logs to a remote storage, such as S3 or GCS. So in case our Apache Airflow system goes down, we have already all the logs stored somewhere else. We could have backup retries, and we need to think about, imagine that you could run each task and it doesn't have, if we retry a task, the results will be the same every time. So that means no side effects. So if we stage transform data, that means imagine that between each task we store the data at an S3 bucket. So if we retry any task, we don't lose any information at all. So yeah, it's perhaps a waste of resources in terms of storage, but I mean, we're more calm, relaxed, knowing that we could retry any task at any moment and the result is the same. So some recipes, we could generate dynamic DAGs. So well, underneath, Apache Airflow checks every py file in the DAG folder and register any available DAG defined as a global variable. This is a bit of a hack, actually. If you know about some Python, we are using the globals variable. So pretty much Apache Airflow checks for any DAG instance on the global level. So we could do pretty much whatever we want. In this case, we're generating on the fly 10 DAGs. But we could do a DAG from whatever. For example, a variable value that it's stored on the metadata DB, a static file. In the case of Idealista, we have a unique Python file, and then we read a bunch of YAML files, which defines all the necessary data for each source or system that we need to process. But it could be an external source based on connections. You could call a MySQL database to check what needs to be run and generate a DAG on the fly. This was pretty much Apache Airflow because I want to talk a bit about data engineering and why I think Apache Airflow empowers data engineers. And I think it's Apache Airflow, it's enabling lots of the best practices for data engineers. So does anybody know about Maslow's hierarchy of needs? I guess so. So this is a really cool slide. I don't know the author at this moment. I have citations and attributions at the end. So if you could check, you can check. But pretty much, this is what I call, what the blog post author called the hiring out of order problem. So companies are focused just on hiring data scientists. For what? They waste 80% of their time just cleaning data or doing stupid tasks, and they pretty much underperform. So we need to think about data literacy, collection, and infrastructure. And that's for what data engineers are for. Pretty much what they're all about. Design, build, and maintain data warehouses. What's a data warehouse? A data warehouse is a place where raw data is transformed and stored into queryable forms. So anyone at the company could just consume that data sets, that data, and enable higher level analytics, be it business intelligence, online experimentation, or machine learning. And this role, of course, we need to master some key skills, such as SQL mastery. So any data engineer needs to master SQL, absolutely. So if English is the language of business, SQL is the language of data. And there are lots of best practices for data engineers, such as load data incrementally. That means, for example, imagine that we have a weekly DAG. We will append data on a table, for example, and load data in a way that we could just retry or rerun it without any side effects. Process historic data, that's called backfilling. Of course, we need to know about the term of partition. So we have to have partitions on our ingest data. So if we do that, we pretty much enforce the idempotency constraint. And there's a really good phrase I like it a lot. So sometimes we can see the forest for the trees. Airflow, the way it's made, if you follow the best practices from the community, it pretty much empowers data engineers and allows us to do what I call functional data engineering. And this is functional data engineering, these bullets. So whenever we design a pipeline, we need to think about these bullets every single time. It will be reproducible. That means it's deterministic, same input, same output. Pretty simple. And idempotent. So rerunning a task for the same date should always produce the same output. In my case, it's safe to rerun a task from 3 days ago, no side effect. Future-proof, that means backfilling and versioning. So data can be repaired by rerunning the new code, either by clearing tasks or doing backfills. If the ETL has a bug, no problem. We'll just rerun it. And this is, this is a graph from the guys from Robinhood. It's a blog post. You can check it later. So this is the typical ETL. It's a really good representation of which operators do we need to use using Apache Airflow. So we have to extract. We could use a sensor and a transfer. We have to do a transformation. We use any action. And we have to load it. Okay, we could use a sensor at the end to check if it's been loaded really for real or not. Well, that's pretty much what I've done, I've been saying already. So, how we are deploying Airflow? Well, we have a role at GitHub, and that's how we deploy Airflow at Idealista. We deploy it locally. But there are more options, such as Astronomer. This is, at this moment, the SaaS for using Airflow. And this was a big hit. Google Cloud now offers Google Cloud Composer. That's Apache Airflow as a service. So that was a really big deal for the Apache Airflow community to know that Google is offering Airflow as a service. So how we use it at Idealista? Well, of course, we deploy it via the Ansible role. We have developed lots of plugins and operators internally, some of them for interacting with AWS Glue and Athena, and Microsoft Teams plugin. We don't use Slack. And AWS S3 to FTP sync operator, so we could sync any S3 bucket with an FTP folder. So, if you have any questions, this is the moment.
Okay, I have a question regarding the scalability of that. So basically what I understood, you can have a single UI just to see like the progress of the tasks. How does it perform when you have, for example, I don't know, hundreds of tasks being run simultaneously?
Pretty much that's not a problem. So I'll tell you. Hold a second. Well, here. So the metadata database can be replicated. The web server can be replicated. We could just put a load balancer in front of it, and that's okay. So the unique problem is the scheduler. That's the unique problem. Because you could run the workers on any kind of executor, even Kubernetes. But trust me, the scheduler, what does is pretty much check the DAG folder and checks with the metadata database to know when it needs to perform a task or to schedule a DAG. But I mean, you really need to have a really high load in order to be a blocker. So companies such as Airbnb, who runs on demand 8,000 DAGs, well, they have a problem with the scheduler. But for any medium or big size company that just uses it for ETLs and so on, that's not a problem.
Thanks. I have a question about Kubernetes. I've read about the workers and the executors in Kubernetes, but do you have any experience running the other components in Kubernetes, like the scheduler, metadatabase?
No, sorry.
No, I'm just wondering.
I guess Cloud Composer is using Kubernetes underneath, but no, I don't.
Okay. And the executor, have you tried them?
Kubernetes? No. I think it's still experimental. I think.
Yeah, we tried, in my company, we tried in summer, but it was really not working at that time. It was like, it will be available soon. So we're waiting for the moment. I'm curious to know if someone has ever tried them. Thanks.
Thanks.
I think it's useful it's useful for data engineering, but you can do almost everything. It's for workflows and maybe I don't know, batch, or maybe just integrating applications.
Yeah, indeed. I mean, I haven't told you about really weird applications of Apache Airflow, but for example, I hope I'm not wrong, but Intel uses it for automating Q&A pipelines, and Airbnb uses it for A and B testing. It's a really heavy modified version of Apache Airflow, and they pretty much created DAG from filling a form, an online form at the web server UI. And I don't know what kind of experiments, of EMB experiments they do. But there are lots of crazy kind of uses for Apache Airflow. But well, the most common case is just ETLs.
I have a question about the implementation of the SaaS Google have. Google have resolved the scheduler issue or the high availability?
No, I don't think so.
So maybe the resolution maybe could be to have an active passive host for even a HA solution?
To be honest, I don't know. I mean, I know the Airflow community, it's aware of the status, but it's really, really difficult to get to the limits of the scheduler. I mean, if you're running, of course, at the scale of Airbnb, that's a problem. But for the most common user of Apache Airflow, it's not a problem.
Yeah, but you need to upgrade the system or shut down machines, you know.
Well, in this case, I mean, all the data necessary for Airflow to run, it's stored on the metadata DB. So if the scheduler goes down, no problem. You just run another scheduler, it will just pick up with the metadata DB and keeps running.
Yeah, it's I mean, with a active passive model.
Yeah, I don't know, to be honest, what's the status of that issue at the level project of Airflow. I don't know if there is any issue open that it could have, but I know on some meetups they have told about that being a problem, but it's just for really, really big scales, not the most common users that don't hit the scheduler limit.
Okay, thank you.
Okay, thank you all.